Previously I talked about how we can get the address of a variable, so how to return the memory address of that variable, and in this lecture we'll talk about how we can store that address. So what is a pointer? Well, a pointer is a variable that can store an address, right? It's nothing much more than just that. So of course this is the address in memory of that variable or a function, but we'll talk about the function part of it later. For right now we want to focus on the memory addresses of variables just to get started with pointers. So just a basic high-level example of what you can do with a pointer. Let's say if demo variable is a float that holds the value 10.5, then I can declare a pointer, let's call it demo ptr for demo pointer, that points to the demo variable. So our demo ptr pointer variable now holds the memory address of demo variable. And again, demo variable is just a regular float variable, right? As we're all familiar with already. So in this way, we can either read from or write to demo variable directly using the demo variable identifier, or we can read from it or write to it indirectly using the demo pointer variable. Because again, that stores the address of the demo variable. So using that, again, you can change the value from that memory address, or you can read from it, and we'll learn how to do that a bit later. But the point here is that we can either access it directly, as we have done it up to this point, simply using the variable name, or you can access that memory location or the contents that are within that memory location indirectly using a pointer. Okay, how do we declare a pointer variable? Well, we use the asterisk symbol to declare a pointer variable. So in this context, we are not going to use it for multiplication. We're going to use it to declare a pointer variable. You need to specify the type of data that the pointer will point to if you want to read from or write to the data at that memory address indirectly using the pointer. You do have something called a void pointer, which we'll talk about later. But typically, if you have an integer variable, let's say demo variable, and later on you want to declare a pointer that points to that integer variable, then that pointer also needs to be of type integer. Otherwise, the compiler won't know how much data to read or to write to that memory address. Right, we talked about type sizes extensively in the first module. So an integer, for example, is 4 bytes. So in that way, the compiler knows, okay, I'm going to write 4 bytes to this memory address, for example, or read 4 bytes from it. And basically, it's just a way to know how much data, let's say the amount of bytes, is at that particular memory address. Otherwise, if it's just some void pointer that can basically point to anything, that doesn't really tell the compiler how much data is at that location. So how much data should it read? How much data should it write to that location, right? So therefore, it makes sense that we have to specify the type to which we are going to point using that pointer variable. So at the bottom of the slide, you can see a quick demonstration. So I have a type. Of course, you're familiar with types at this point. That can be an integer, a float, and so on, as well as custom types such as classes and structs. And we'll discuss those in more detail in this module. So you have the type, then you have the asterisk, the name of the pointer, so in this case just demo pointer, and you can end that off as a semicolon at that point. That's a declaration statement then. But because it can contain garbage, just like a regular variable, it's important to initialize it. So always initialize your pointers. Uninitialized pointers can point anywhere, basically. So this means you can access memory that you should not be accessing, because again, a pointer points to an address or a memory location, and you can accidentally write to that or maybe corrupt some sort of memory, right? So you want to make sure to initialize your pointers right away. You can either use 0 for null, or you can use a null macro, which will also set it to null, or you can use null pointer, which was introduced in C++ 11. Now, null is not really a valid address, but this is the only integer that you are going to assign to a pointer other than an address. So if it's null, that means it's pointing nowhere. If it's uninitialized, so it just contains some garbage, that means it can point to anywhere. It can point to some memory address that you have no business accessing. So instead of pointing anywhere, you want to set your pointer to point either nowhere by setting it to null, or you want to set it to a specific address right off the bat. So pointing to some address of some variable or function. So even though null is not a valid address, that's fine for pointers, even though it's sort of an invalid address. It's kind of an invalid value for an address, but that's fine. That simply means that the pointer is pointing nowhere. Okay, a few examples of pointer declaration. These declarations are equivalent. So you have int x, int y, and int z. We prefer that int x example, that pointer example. So we prefer to place the asterisk before the pointer variable identifier. So in the following statement, only x is a pointer variable. Y and z will be regular integer variables. They will not be pointers. Only x in that example will be a pointer. So the compiler doesn't care about the white space or the placement of that asterisk character, right? But for readability and to avoid confusion, it's a good idea to place the asterisk before the variable identifier. So to prefix your variable identifier with the asterisk. Another example of this, here we have int x, y, and z again. Variables x and z are integer variables. Variable y is a pointer. Again, make sure to initialize y. You can either use list notation as we've discussed previously for regular variables, or you can initialize it after this declaration statement. Okay, so in this example, you see we have a table to the right. In the first column, we have the value stored within some variable. To the right, we have memory addresses. Some of those are faded because we don't care what they are. It's just an example. So if you go and look at this in Visual Studio, the addresses will be different on your machine. And each time you run it, that will also be different. Because each time you run the program, it will go and set aside memory for your variables. And it won't always do that in the same memory address, of course. So here I declare demo var, I set that to 12, and then I declare a pointer called demo ptr, and I initialize that to null pointer. So the value of demo var, and you can see in the table to the right here, the value of demo var is 12, but the value stored in demo pointer is just 0. It's not really a valid memory address, but it basically means, okay, this pointer points nowhere, instead of just pointing anywhere. You will also notice in the second column that both the demo variable and the demo pointer each have their own address in memory, so they are both variables and they both have their own address in memory. Right, now that we have a pointer variable declared, we can go and save the address of some variable into that pointer. So we talked about the address of operator before. It's a unary operator that returns the memory address of its operand, and that can then be stored in a pointer. So demo var and demo ptr, the demo variable and the demo pointer, now refer to the same memory address. Both variables, though, are saved in their own respective memory addresses, so the pointer is a variable in itself, and it will have its own memory address, but it is also used to store the address of some other variable. So here's that same demo. We have int demo var, set that to 12, we declare and initialize a pointer to null pointer, and then maybe later on we decide we want to store the address of demo var in that pointer. Then we get the address of demo var using the address of operator and then store that in demo pointer. In this example, once again, I have demo var, which I set to 12, and I declare demo pointer, and in this case, instead of setting it to null, I set it to the address of demo var, and in the table you can see the value stored in demo pointer is the address of demo var in memory. So it doesn't store 12, right? It's not a copy of the value that is stored in demo var. It will literally store the address of the variable that it points to. So in this case, once again, demo var. Okay, we've seen that a pointer stores some memory address, right? Now, how can we read from or write to that memory address? Let's say we want to modify the variable that the pointer is pointing at. Well, that is where the referencing comes in. Now, in relation to pointers, the asterisk can be used in two different ways. It can be used as a sort of type modifier in the declaration of a pointer variable. The operand is declared to be a pointer variable as opposed to a regular variable, right? If you declare some variable and you prefix the identifier of that variable with the asterisk, then that becomes a pointer variable now. And it can also be used in dereferencing. It's also referred to as indirection or the indirection operator because you are indirectly accessing that memory address or reading from or writing to some memory address, right? So this can seem a bit confusing at first because you now use the asterisk in two places, but just think about the current context. Are you declaring a variable? You're already familiar with declaring a variable, so in that case, it's a type modifier. You are declaring a pointer variable, or are you reading from or writing to the memory location, right? Just like you use a regular variable to do console output, for example. If you want to print that out to the screen or do some mathematics with that, demo variable plus 3, for example. Well, you can't do that with the pointer directly because the value stored in the pointer is just an address. So you have to dereference it first. It will then basically fetch the value that is stored in the memory address where that pointer is pointing at, and then you can do mathematics with that or, print it out, whatever you want to do with that. You can also write to it, so you can change the value stored in that memory location. Now also an important point is that it is an error to dereference a null or uninitialized pointer. If you have an uninitialized pointer, once again, that will point anywhere basically. So you could be accessing memory that you should not be accessing. That is why we set it to null pointer as soon as we declare it, or we set it to some address that we want it to point to. Then I also mentioned that null is not really a valid address. We simply use it to set that pointer to point to nowhere basically. So again, it's not a valid memory address. So make sure that you know what you are dereferencing, that the pointer is initialized properly and that it is not null. Here's a quick example. In demo var set that to 12, I declare demo pointer and set it to null. Then later on I decide, okay, I want to store the address of the demo variable into the demo pointer. So I go and do that with the address of operator. Then I want to print out what is stored in the memory address pointed to by demo pointer. So I have to go and dereference that. So you can see the two different contexts here. The declaration, where I initialize it to null, and then also where I use it. So in this case, I'm just doing a console output, but that will basically fetch the value that is stored at that memory location. Okay, so let's say we have demo pointer, and that stores the address of demo var, and you want to print out the value stored in demo var. You can do cout demo var. The compiler is going to recognize that demo variable. Now on the second line here we do console output, we use the asterisk, and we do demo ptr. So in that way we dereference the pointer. So instead of printing out the memory address now, it is going to print out what is stored in the memory location where it is pointing. So currently it is pointing to demo var in memory, and that contains 12. So it's going to print out 12, right? At the top here we have int demo var, which I initialize to 12. Then we declare demo pointer. I initialize that to the address of demo var. Then I go and dereference demo pointer, and I set it equal to 15. So 15 is now stored in the location pointed at by demo pointer, which again is demo var. Then I can also go and print that out. So in both instances here, I am setting a value at the address where demo var is located in memory. So I set that to 15, and I also indirectly access that once more to print it out. So cout demo ptr. So I dereference that demo pointer, and that will print out 15. So again, we can either use demo var directly to make direct changes to what is stored in that memory location, or we can access that memory location indirectly using a pointer, and then we can dereference that pointer to read from that memory location or to write to that memory location. In this section I want to print out the value of the pointer. Up here we set it to null. We declare a pointer called demo pointer. I set it to null, and then I print it out here. So the value of, or in other words, what is stored in demo pointer. Here we set the demo pointer to point to demo variable. So in other words, the address of demo variable gets stored in this demo pointer. Then I go and print demo pointer out again. So the value that is stored in demo pointer. Okay, well, instead of running this, I'll put a breakpoint right here on this final line. Then I'll run the Windows debugger. Go to debug, Windows, memory. I'll bring up memory 1. Okay, I'll open it maybe to the left side here. Then I'll do another one. So I'll go debug, Windows, and memory 2. Might be faster if you remember those hotkeys. Okay, on the left one here, I'll do the demo variable. Type ampersand demo var to get the address of demo var. Press enter. You'll see that shows up right here. We get 0C, which is 12 in hexadecimal. To the right here in memory window 2, I'll do demo pointer. Now this has capital P. This here is the address, so where the demo pointer variable itself is stored in memory. Remember that is a variable that holds some address, so it's still a variable, it is still stored in memory. To the left once again, this is the address where it is stored in memory, and then in memory this is what it contains. You can also right click on this and select sign display, for example, and then you get plus 12. Alright, I'll just go back to hexadecimal. To the right we have the location in memory where the pointer is located, and then also what it stores. Now this can be a bit weird because it's not going to read as you expect, but we expect that to store the memory address of the demo variable. because that is what it is assigned to right here. Demo pointer is equal to the address of demo var, but the order is just going to be reversed a bit. So if you read it from right to left instead of from left to right, we have 0, 0. And then if you look over here, we have 0, 0, 9E. Here we have 9E. Then we have F7. We have F7. And then A8. And here to the right now we also have A8. So let's just do that one more time. If we run this program again, those memory addresses will change. It won't go to the exact same addresses. So I'll just run the debugger one more time. Demo variable on the left and demo pointer on the right. So we'll read it from the right to the left once more. 0056, and here we also get 0056. Then we have FA and 4C. Similarly, we have FA and 4C right here. Once again, the pointer variable is a variable that gets stored in its own memory location, but it stores the memory address of some other variable, or basically it just stores a memory address, alright? It can be of a variable, it can be of a function, as we'll see later as well. I'll bring up the output of this program. So we do the printout of that pointer, what is stored in that pointer, after setting it to null. So we get a bunch of zeros. Then we set the value of that demo pointer to the address of the demo variable, and then we print the value of the demo pointer out again. And of course this will be different each time you run it. So if you run it, you'll get a different value. But I get 0056FA4C, and if I check it to the left now, right here in this first column, that will match with that. Right, those two values will match. So if it's difficult for you to read on the screen right now and so on, go and test it, and of course once more you'll get different values than I do. I'll just stop that. Okay, so I hope this demonstration was useful to you.